In this video, we're going to take a look at projectile motion equations and if the equations are going to actually intersect at the same time. First thing, we're going to look at it graphically, kind of see if we can figure out which ones are intersecting, and then we're going to look at the algebra behind it. So in your calculator, you're going to want to put in the three different bugs, bug A, bug B, and bug C. So I already have that typed in. If you want to pause the video for a second, just type that in your calculator. Please do that. After typing in, you want to make sure your mode is on radians, not degrees. So it probably is on degrees from our last section. Make sure you put your mode into radians. And then your window, I put 0 to 5. Well, that might be a little high, but we could always hit the on button to stop it. 0.005 for the t-step. And then I looked at the window that was on the pre-made sheet, 0 to 12 and 0 to 6 for your x and your y. Okay, then from there, if you hit graph, actually let's go back to the y equals for a second. So our blue is A, our red is B, and our black is C. You may not have the color calculator, but at least you can see as we're going which one is which. I'm going to hit graph. So we're going to see them going. It looks like the first two are kind of coming from the same location. And then the blue graph looks like it intersects the black graph at the same time. It does intersect the red, but the red has already gone past that point. So that's our goal, is to kind of figure out what's happening there. First thing, it just asks you to label the paths of the three bugs, so let's do that right now. Again, blue was A, red was B, and black was C. And then again, it looks like the A and the C collide, but we're going to go through and do the other ones to show why they do meet at the same time or not at the same time, and do that algebraically. So in this video, we're going to look at the first algebraic. I'm going to stop it after that, and you'll look at the second video to look at the other two algebraic, because these are kind of lengthy problems each, so it'll give you a chance to kind of regroup, digest what's going on, and then move on to that second video. Okay, so for bug A, the goal is, that looks like one of our trig function situations. I'm going to solve for cosine t and sine t first, use my Pythagorean to put it in rectangular. So the goal algebraically is to put each in rectangular. And then we're just really solving a system of equations in rectangular format. So it kind of goes back to what we did right before this unit, the systems of conics. A little bit of that and a little bit of maybe just linear equations that we're finding. So remember, for this one, cosine squared plus sine squared is 1. And that's our first rectangular equation. We want to find the other one, which will obviously be a little bit easier, so bug B. One second. That's our second equation if we then do a substitution. Now the goal here is to figure out where do these intersect. And then we'll have to go back and figure out if they intersect at the same time. So we're going to go and plug in the 5/3 x into y. This gets a little tricky solving wise. Not terribly, but a little bit tricky. So actually, for calculator purposes, if you put in 5/3 squared divided by 25, you can do that together. It ends up giving us 1/9. So we still actually have what looks like an ellipse equation. But now if you add 1/64 to 1/9, you're going to get 73 over 5/76. And then really, if you just flip that, take the square root of 5/76 over 73, you're going to get x is about 2.81. So do that in your calculator. And then if we go back and multiply that by 5/3, because we have that equation of y equals 5/3 x, we're going to get a y value of 4.68. So this is where the graphs would intersect, or do intersect, if we're just looking at it rectangular-wise. But if we want to see if they get there at the same time, we need to now plug in those values to see if that happens. Again, make sure you're in radian mode still, like we did for the graphs, and we'll check out bug A and bug B. So for this, if you do 2.81 divided by 8 and do inverse cosine, comes out to be about 1.21 seconds. Do the same thing for bug B. And you get a different time of 0.94 seconds. So bug B gets there sooner than bug A. Whoa. Sorry about that. So therefore, they do not collide because they don't reach the intersection point at the same time. So we're going to take a look at the other two. Again, it kind of seems like we already know that A and C are going to collide, but we are going to take a look at those algebraically. So you'll take a minute and make sure you have everything down for this, and then start up the second video.